All right, so for this video here, we are going to be introducing slope and also the slope formula. But first, we do want to review rate real quick. So using the table, find the rate of change. So whenever we're looking at a table, we do want to read them from top to bottom. So the right-hand column, the distance or the y's, it's 50, 100, 150. It's going up by 50s. And then for the other column, the time, the hours, or the x's, that's going to be going from 2 to 4 to 6, going up by 2's each time. So we can kind of summarize this in a sentence. So each time the x increases by 2 hours, the y increases by 50 miles. So now for our rate of change, for this example here, we're going to do the change in distance divided by the change in time. So remember the distance, the dependent variable, that goes with the y's, distance goes with the y's, and time goes with the x's. Time, the hours, goes with the x's there. So here we already have our numbers in. Change in y's was 50. The right-hand column went by 50s. Left-hand column, the x's, went by 2. So, and we can actually do this division here. 50 divided by 2 makes 25. So the car or the bicycle or fast bicycle or whatever it might be is traveling at a rate of 25 miles per hour. And you could do mph here if you wanted, or m/h for the rate. Okay, so now that we have reviewed rate, let's go ahead and look at slope of a line. So slope of a line is the measure of the line's steepness, how steep it is. So we're actually going to put like a number value for the steepness of a line. So the bigger the number, the steeper the line. So slope, the way we calculate that, right, it's going to be rise over run. So if you're thinking like XY pairs, like coordinates and stuff, the second number, the Y coordinate, that's going to tell you how far up or down your coordinate point is. So that's going to be your rise. It's the change in y's, how far between the two y values. Now the run, again, thinking XY pairs, the X value tells you how far left or right something is, and so that goes with your run. So how far between the two X's, okay? Now, when we're finding rate, we're basically doing the same thing. Change in dependent variable, which is the Y's, divided by change in independent variable, which is the X's. But again, remember with slope, we're finding how steep a line is, whereas with rate, we're finding like miles per hour or dollars per hour if you're working at a job or something like that. So that's the main difference between the two, but how you find slope and how you find rate, super duper similar. So here we're just going to do a quick illustration showing that the slope of a line is the ratio of rise to run for any 2 points on the line. So again, ratio, think fractions, right? So slope, that's going to be the ratio of rise to run, rise over run. And again, rise over run basically means the same thing as change in y's to change in x's. Okay, so looking at this line here, we're going to go with any 2 points. So there's 4 points there. So for rise over run, we're going to go from this point to this point here. So remember, rise, that's your difference in y values. So from this point here, we're going to go up, right? There's your change in y's. That's going to be 1, 2, 3. And then the run is your x values, how far left or right it goes. In this case, to the right, 1, 2, right there. So rise to run is going to be 3 to 2. And now if we do these 2 points here, right, we're going to go up and then we're going to go over. The rise is going to be 3 and over is going to be 2. And then we can look at these 2 points here, up 3 over 2. So you can see that the ratio between the rise to the run doesn't change on this line here. It stays the same. It's always going to be 3 over 2. Now check it out. We have these ones here, but what if you choose like this one here and this one all the way up here? Well, that's going to be up 6 and over 4. So 6 over 4, or the ratio of 6 to 4, still reduces to 3/2. So you're going to end up with the same value no matter what points you pick on this line. Okay, so now we're going to look at an example. So we're going to graph and then find the slope of the line that passes through these 2 points here. So step 1, graph. So our first coordinate point there, -3, 4. So -3 on the x and 4 for the y. So that ordered pair is graphed right there. And then 1, -2, 1 on the x is there, and -2 on the y right there. So the line that we're finding the slope of, boom, right there. So now we're ready to go. So remember, slope is rise over run. So whenever we work with graphs, generally speaking, we're going to work left to right. So we're going to start with the leftmost point, which is this one right here. And then we're going to do rise over run. So first we're going to go down in this case, and then over in this case here. So we're going to go down 1, 2, 3, 4, 5, 6. So we went down 6. So that's a -6 because we went down. And then we're going to go to the right 1, 2, 3, 4. So we went to the right 4, so that's going to be 4 for the run. So we do want to clean this up a little bit, reduce it if possible. So we can either write it as -3 over 2 or -3 halves. So with slope, we can do either one. We generally speaking don't put the negative in the denominator. And then the other thing too is that we are going to leave these as improper fractions. Do not make it -1.5 or don't do mixed numbers. Slope is supposed to be rise over run, so just leave it as an improper fraction or just a regular fraction. Okay, so now we're going to find the slope of this line right here. So when you already have points on it, like the last one that we did, fairly easy to know where you're going to start and where you're going to stop. Well, in this case here, we're not quite sure where we're going to start and stop. So we are going to be looking for on this line what I like to call nice points. Now, this is not like a math phrase, but it's just one that I like to use for these examples here. So here we go, finding nice points. There's one right there. And keep going. No, no. No, no, there's one there. Keep going. No, no, no. Another one there. So this line actually on this graph has 3 nice points. So the nice points go through the grid lines. Okay. So like this one right here is not a nice point. We can easily see that that's going to be a 5, but we're not sure what the X value is going to be. And then like this one here, you can tell, oh, that's a 1 on the X, but not quite sure what the Y is. So it's got to go through a horizontal line somewhere and also one of the vertical lines. Okay. So remember, slope, that's going to be rise over run. And with rise over run, with slope, we only need 2 points, okay? So I normally like to start on the y-axis when that's available, and then we go to the right, okay? So we're going to start on the leftmost point and then work our way to the right. So here we go, slope, rise. So it's going to go up, and then it's going to go to the right. So, and then we're just counting squares. So for the rise, it's going to be 1, 2, 3, 4. So we went up 4. So the rise is going to be a 4. And then we're going to go over to the right, 1, 2, 3. So the run is going to be a 3. The run is going to be a 3. So there's our slope, 4/3. Don't change it like to a mixed number or anything like that. Don't do 1 1/3. Slope is supposed to be just a fraction, not a mixed number. Let's have you go ahead and try this one out on your own. So pause the video, then come on back, see how you did. So remember, slope, that's going to be rise over run. And in order to calculate rise over run, we do need to find 2 nice points on our graph. So there's 2 right there. This graph has more than 2. There's one here and one here, and then there's another one there and another one there. So this one has like 4 or 5. Some graphs will have more. Some will have as little as 2. So remember, the nice points, they go through both grid lines. They go through a Y grid line and an X grid line. So like at this 4 here, we can see that it goes straight up to the 4, but we're not quite sure where it lines up on the Y, so not a nice point. At the 15, we have the graph there, but we're not quite sure what the X is, so not a nice point. This point right here, which is a nice point, it has a 3, and it goes straight over to the 12, so this one is a nice point. So after we figured out our nice points, now it's time to go ahead and calculate that rise over run. So remember, we always go from left to right. So start at the leftmost point. That's going to be right here on the y-axis. And then in this case, we're going to go down, and then we're going to go to the right. So the rise, that's going to go down. In this case, it's going to be 6. Now, if you mess this up when you try this on your own, look at the y's. They go by 3. So 3, 6, 9, 12, 15, right? The y's go by 3s. So what we say then is that the y scale is 3 because the y's go by 3s. Now, for counting the run, well, the x's go by 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So the x's go by 1, so we say that the x scale is 1. So when we're doing rise over run, we do need to look at the scale of the graph. So in this case here, let's look at the run. It's over 1, 2, 3. So there's our run is a 3. So it went down 6 over 3, so that's going to be -6 over 3 for our slope. Now this one does reduce down to an integer, so -6 divided by 3 makes -2. So our answer isn't even a fraction, it's just an integer. So anytime it reduces to an integer, we do need to make sure and reduce it to an integer because that's the best way of writing this answer here. Now we're going to find the slope of two special lines. First up, a vertical line there. Remember, for finding slope, we need two nice points. There's a ton on here. We're just going to use this one here, 2, -3, and also 2, +1. So those would be the 2 points we use. Remember, slope, rise over run. We're just going to start here, work our way up. 1, 2, 3, 4. The rise is 4, and the run, it goes up 4 and over nothing. So no matter how many zeros you use, you'll never get 4. So you cannot divide by 0. So this type of slope here is called an undefined slope, or also no slope, are the two different words for these vertical lines here. Now let's look at a horizontal line. Again, 2 nice points. We'll just use this one here, -4, -3, and this one here, 2, -3. Rise over run, it's going to go up 0. And then it's going to go over 1, 2, 3, 4, 5, 6. 0 divided by 6 makes 0. So your horizontal lines are going to have a slope of 0. Vertical lines are undefined. So just putting these all together, all of our different slopes, again, when we look at graphs, we're going from left to right. So from left to right, if the graph is going up or increasing, that is going to be a positive slope. If the line from left to right is decreasing or going down, that's a negative slope. Now the 0 slopes, those are your horizontal lines. It's not going up or down. Its change is 0. And then the undefined slopes, those are the vertical lines, straight up and down. If you're thinking skiing, this is a cliff, and we don't ski on cliffs, we just fall. Now we're going to go ahead and nail down the actual formula for finding slope of a line. So remember, we're doing rise over run, change in y's over change in x's. So we're going to use this graph over here to kind of illustrate our formula. So here's 2 points that are on that line, and we're going to call this point point number 1, and this will be point number 2. So again, we're going from left to right. So let's do rise over run, or rise and run in this case here. So the rise, that's going to be, remember, you're looking at y's, right? For up to down, you're looking at y's. So we're going to take the y from this point, point 2, and we're going to subtract the y from point number 1 right there. So that's why it's y2 minus y1. This is the y value from point 2 minus the y value from point 1. And these are subscripts, y subscript 2 minus y sub 1. But we normally just say y2 minus y1 just to make it fast. Okay, now the x is basically the same idea. So there we go. There's our run. We're taking the x value from the second point minus the x value from the first point. So like if this is like a 9 here and this is like a 5 here, you're just doing 9 minus 5, and that's going to make 4. But this is the way we write it. The x from point 2, so this x here, minus the x from point 1, so this x right here. Okay, so there's your formula there. y2 minus y1 over x2 minus x1, and that's the formula for slope. Now, I do recommend you get a formula section. I recommend you just put it in the last like 3-4 pages of your notebook. That way all your formulas will be there, and get this one written down. So now we're going to go ahead and find the slope of the line that passes through 1, 5 and 3, 8. So whenever we're finding slope, when we're talking about like slope-intercept form and that type of stuff, the variable m goes with slope. So asking for m, asking for slope, same thing. So remember, slope, that's going to be rise over run. Your rise, that's going to be your change or difference in y's, and then the run is going to be the change or difference in x's. So remember, with these ordered pairs or coordinate points, it's x, y, and then x, y there. So our change in y's, we're looking between the 5 and the 8, the second of the two numbers in each pair there. So with this, when we had graphs, we could just count squares. Well, here we don't have a graph. We could put it on a graph if we wanted to, but in this case here, we're just starting at 5, we're ending in 8. How many more numbers did we have? Well, that's 5, 6, 7, 8. So that's going to be 3 more numbers there. So that's your rise. You can kind of even do this in your head using like mental, like just counting, or you can just use your fingers. And then for the run, that's going to be your difference or your change in x's. So that's the first number from each pair. So we're starting at 1, we're ending at 3. So how many more numbers did we use? Well, 1, 2, 3. So it's 2 more numbers to start at 1 and then end at 3. So there's going to be your slope, 3 over 2. Now, you can use this method here, which is really similar to the method that we used with the graphs, or you can use the formula. So that's going to be y2 minus y1 over x2 minus x1. So most of the time you do have to identify which one is 0.1 and which one is 0.2, and you can choose these at random. Most people just choose the first point to be 0.1 and then the second point to be 0.2. So this y2 right here, that's talking about the 2 there is talking about 0.2, and then the y is saying the y value from 0.2. So 0.2, the y value is going to be an 8, so we replace the y2 with an 8. Now y1, that's 0.1, and it's the y value. So 0.1 is this one here, and then the y value is going to be a 5. So we replace y1 with a 5. Now x2, that's the second point, so point number 2, and it's going to be the x value, so that's going to be a 3. So x2 gets replaced with a 3, and then x1, that's the point number 1, and then the x value, point number 1, the x value is going to be a 1 there. So x1 gets replaced with 1. Now you just do order of operation or subtraction, which is also why these are called difference in y's, difference in x's. So 8 minus 5, there's our 3, and then 3 minus 1, there's our 2 there. So 2 different ways of finding slope. Pause the video and try this one out on your own, then come on back, see how you did. So slope, or m from slope-intercept form, is rise over run. Rise, that's going to be our change in y's, and the run is going to be our change in x's. So over here, for our y values, we got our 2 ordered pairs, xy and xy. The y values, that's an 8 and a 5. So we're starting at 8 and we're counting to 5. Now, if we're on a graph, we can just count squares, but we don't have the graph, so we're just counting numbers. So starting at 8, ending at 5, that's going to be 8, 7, 6, 5. So we actually counted backwards 3 or down 3. So the rise is going to be a negative 3. Now for the run, or the change in x's, starting at negative 1, ending at 3, this one does cross over 0, so it's a little bit tricky to visualize. So here we go. Starting at negative 1 and ending at positive 3, we're going to count 1, 2, 3, 4. So this one's going to go over 4, or to the right 4. So that's going to be our run, is going to be a 4. So our slope is negative 3 over 4, or negative 3/4. Now, if you do like using the slope formula, here it is here, y2 minus y1 over x2 minus x1. So y2, that's going to be the y value from point 2. So over here, normally the first one we call point 1, and the second one we call point 2. So y2 is the y value from point 2. There's point 2, and its y value is going to be a 5. So it gets replaced with a 5. y1 is the y value from point 1. There's the y value from point 1 is going to be an 8 there. The x value from point 2, or x2, that's going to be a 3. And then the x value from point 1, that's going to be a negative 1 there. So now we just go ahead and do the subtraction. 5 minus 8, so we're thinking we have $5 and we have to pay $8. Well, you don't have enough to cover how much you have to pay, so that's going to be a negative 3 in this case here. And then anytime we subtract a negative, in our brains we just think, change it to a plus. So 3 plus 1 makes 4. So there's 2 different ways of doing this. Now, when you are using like this arrow method type thing here, just kind of doing it in your brain, I highly recommend put the change in y's, or the rise, up on top, and then the change in x's underneath the 2 ordered pairs. So that way, when you have it written down here, it's negative 3 over 4. If you have it the other way, then it's kind of backwards. So for this example, do want you to try this one out on your own, writing nothing down using only mental arithmetic. So go ahead and pause the video, try it out, then come on back and see how you did. So for slope, that's m from slope-intercept form. That's going to be rise over run. The rise, that's change in y's. Now this little triangle here, that's a Greek letter delta. It's translated as change in. So this literally means change in y's over change in x's. So for change in y's, we're looking from negative 2 to a negative 5. So this one here with the negatives might be kind of tricky to visualize. So here we go. Starting at negative 2 and then going to negative 5 there. We're going to count backwards. 1, 2, 3. Or it got colder if you're thinking degrees. 2 degrees below 0, 5 degrees below 0. It got colder by 3 degrees, or it went down 3. So negative 3 for the rise. Now for that change in x's, going from 3 to 8, and again, we're just counting numbers. On a graph, we can count squares, but here we're just counting numbers. So 3, 4, 5, 6, 7, 8, right? So that went over 5, or to the right 5, or I counted 5 more numbers or squares if we're thinking on a graph. So negative 3 over 5, or negative 3/5. So So we have these 2 points, 6, 3 and R9, and we're going to find the value for R, so that way the slope between these 2 points is 3/2 or 3/2. So lots of different ways of going about this. I'm actually going to show 3 different ways. The first one and most straightforward is just using the slope formula and then replacing the m, the y2, the y1, the x2, and the x1 with the values up here and then solving. So it's the most straightforward way of doing it, and most students like using this way the best. So here we go. So we're just going to go ahead and replace all of these with numbers and variables from the question up here. So the slope, the m, that's going to be 3/2. So 3/2 replaces the m. So y2, that's the y value from point 2. So point 1 is the first one, point 2 is the second one. So the y value from point 2 is going to be a 9. So y2 is a 9. And then y1, the y value from point 1 is a 3. So now the x2, the x value from point 2, that's going to be just r. And then the x value from point 1, that's going to be the 6 there. So there we go. So now we have our formula all filled out with the values. Next up, just clean it up as much as we can. So any type of order of operations, in this case, we just have the 9 minus 3 that we can clean up and call that 6. So now we have a proportion here. Now with this proportion here, so most proportions you cross multiply and then solve. So that's what we're going to do here. So we're going to start out by doing 3 times r minus 6. So there's 3 times r minus 6, and then the other cross multiply is the 2 times 6, 2 times 6 there. So with this right here, this multiplication here, that's going to be distributing style multiplication. So 3 times r, 3r, and then 3 times a negative 6, that's going to be a minus 18. And then this is just regular second, third grade multiplication, 2 times 6, 12. Now we have a 2-step equation. We've already solved a bunch of those already. So let's go ahead and undo the minus 18 with a plus 18 to both sides. So that leaves 3r minus 0 is just 3r. 12 plus 18 is going to make 30. Next up, undo the multiply by 3. Divide by 3 to both sides. So 3/3 here is just 1r equals 30 divided by 3 is going to make 10. So there we go. So the value for r is going to be 10. All right, so we're just going to go over a couple of more ways of looking at the same question. These are going to be a little bit more intuitive, like you just got to think about it a little bit more versus just simply using the slope formula. So here's our 2 points here, and between these 2 points, we want the slope to be 3/2. So there we go, 3/2. So remember, this is rise over run. So now looking between our 2 points here, what's the rise? Well, we're starting at 3 and we're going up to 9. So that's 3, 4, 5, 6, 7, 8, 9. So that's an up 6. So now in order to maintain this 3/2, if we go up 6, then how far over are we going to go? Well, this has to be equivalent. So 3/2 and 6/4 are equivalent fractions. So rise over run 3/2 is the same as going up 6 and over 4. So for our run, we're going to start at 6 and we're going to go to the right 4. So 6 plus 4 is going to equal 10. So that's going to be our value, our x value when the y value is 9. So like when we have these slopes here, like 3/2, and you find out that your rise is like 30, then the run has to be 20. 30/20 equals 3/2. Or if you find that the run is like 10, right? You multiply by 5 here. Then if the run is 10, then the rise has to be 15, because 15/10 is also equal to 3/2. So using that equivalent fractions type idea can also get you this 10 here instead of using just a slope formula. So again, this is a little bit more of an intuitive. You got to think equivalent fractions in order to come up with this method here. Now, another way of looking at it, which is super duper similar, is like on a graph. Okay, so we're going to start in this case here on 6, 3, 6 on the x, 3 on the y there, and now we're just going to apply this slope 3/2. So we're going to go up 3, 1, 2, 3, and over 1, 2, and it puts us right here. Now, what are we looking for? Well, we're looking for when the y is 9. So here we go right here, the y is a 6. That's not what we're looking for. So let's keep going. So up another 3 and over another 2, and boom, now we're right there. And check it out, the y is a 9. And in this case here, the x, which is what we're looking for right there, the r, that's the x when the y is 9, is going to be a 10. So we can also look at this on a graph. Now, what did we basically do on this? Well, we did 2 slopes, so that's 2 rises and 2 runs. So we equivalently went up 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4 is basically what we did, which is what we did over here with this example here. Over here, we're looking at it on a graph, so if you're visual, this might be a way of thinking about it. If you just like adding and subtracting numbers and working with like equivalent fractions and stuff, you can kind of go that direction instead. So remember that slope is the measure of the steepness of a line. Now, if we're talking about slope-intercept form, that's going to be the value for m. That's going to be rise over run. Change in y's over change in x's. And again, this triangle, that's the Greek letter delta. It stands for change in. So change in y's over change in x's. If we're thinking like a word problem or rate, that's going to be change in the dependent variable divided by or over the change in the independent variable. And then the formula for the back of our notebooks in our formula section, y2 minus y1 over x2 minus x1. And again, this is the y value from point 2 minus the y value from point 1. And then same idea with the x's there. Now, as far as like generic slopes, positive slope, if we're reading from left to right, the line is going up or increasing. From left to right, if it's decreasing or going down, that's negative. Zero slope, it doesn't change. It's not going up, it's not going down, it's staying the same. That's your horizontal line has a 0 slope. And then for undefined slope, that's the straight up and down. It's the vertical lines. If you're thinking skiing on a snow slope, then it doesn't have a slope because it's a cliff. And you can't ski on a cliff, you just fall.